We started our company in 2018, and basically the problem that we saw was that people are not careful enough with the most precious piece of information that they own. And I might be giving it away as the founder of Genomes.io, but for us that is of course your genome, your DNA information. Your genomic sequence, another word for that. In your lifetime you will have multiple phone numbers, multiple home addresses, multiple bank accounts potentially, but you will only have one genomic sequence. It is very identifiable, it has an exponentially growing monetary value, and we're only at the very early beginnings of what it can reveal about you, right? When it comes to conditions, ailments, diseases, not only for you but also for your offspring, for the next generation. It is a very precious bit of information. If we know that, then why is it that we are so incredibly careless with it? Where we see the fact that people are not cautious or not careful with it is when we look at the market. So, and these are statistics that are slightly older because we stopped in 2023, but 2024 was also actually very turbulent on this specific level. But when you look at the market, not the decentralized end of the market, because that's of course where we are a solution, but when you look at the market, you see that genomic data is being exploited, genomic data is being hacked, and genomic data is being used for other purposes than you personally originally consented for. When we go to the exploitation, you need to look in the direction of direct to consumer genetic testing companies. The most notable example of that, 23andMe, and it was yesterday announced that the assets of 23andMe that had to declare bankruptcy because they were hacked in October 2023, whereby 6.9 million people suffered because of that hack, because their data was being cross-sold on a dark web forum. This is not Big Brother language. This actually happened in 2023 and over into 2024. This company was bought for $256 million by another biotech pharma company. That was just announced yesterday, right? The transactions that you see are for hundreds of millions of dollars, right? Your genomic data, and these are merely data transactions. This is not any kind of additional analytics. This is not kind of refined genomic data. These are data transactions that go for hundreds of millions of dollars, whereby people basically, or these companies, have cross-sold your information to other organizations. In the pharmaceutical sector, in the research sector, using it for commercial scientific research or otherwise. The gist of it, of the most important thing here being that you do not have a say. You as the individual patient who waived your data in the first place are not asked what is being with your data at a later point in time, right? And that's what we felt very strongly about. We said, well, that's what needs to stop. And this is why we started building Genomes.io. So what do? In essence is, here's a quick representation of what is happening. For the individual, they lose their privacy, they lose their control, and they're not paid for any sharing of their data. Any kind of commercial gain that is being made by these companies that cleverly took your data from you, by the by, you have paid them for that because you were interested in a genetic ancestry report or a report knowing more about your dietary requirements, whether you have it in you to become an athlete. Those are all things people pay for in the consumer market, but at the same time, the laboratory says, nice and lovely, thank you for paying me $200. Now I will sequence your data and I will keep the data and gain the commercial rights over it so I can cross-sell it, right? So you are, as an individual, you lose your privacy, you lose your control, and you're not being paid of any of the benefits that the intermediary basically is getting from keeping your data. At the other end, we've also noticed that pharma and biotech, kind of the big players, are not necessarily happy either, because they are held liable for what's going to happen with the data, they only get the data, as I said before. So it's a very poor data acquisition model, because for someone that might know the health tech market, it's not only about the data, but also for the follow-up questions. It's not only the genotypical data, it's also the phenotypical data. And phenotypical, another word for that, is the patient information. You really learn about what's happening, and if you can develop a drug for someone, if you basically have both, essentially. So it's about the follow-up questions, but with this data transaction model, they're not able to. So there's no ability for enrichment. So what we say as Genomes.io is, well, let's cut out the middleman. Let's be this decentralized infrastructure of virtual vaults to which you can upload your data, and then once it's on there, you and only you have the key to that vault, right? It is end-to-end encrypted. It is cloud-based, and I'll get into the components later. But because it is on our infrastructure, we can then provide you, first of all, with more information about you, very similar to what these direct-to-consumer genetic testing companies are doing, but we run the report in an encrypted environment, meaning that we would never need any of your data to run the results. It's all done in an encrypted way. You receive the report in your dashboard, you're able to read the report, but there's never any data leakage coming out of the vault to which you and only you have the key. And that also then goes for pharma, biotech, or other organizations that might want to use your data, because we're always talking, I just want to kind of raise that caveat that it's not only the big pharma that's after your data. It could also be, for instance, the British Heart Foundation, looking to advance their research, develop their understanding, right? It could be for a charitable purpose. It could be a rare disease a charity or whatever more that wants to understand specific things better. The gist of it is that these organizations can work with our infrastructure and can work directly with you, because how it works is you would receive a notification on your phone saying the British Heart Foundation wants to do research, you fit the demography, you will be compensated in Genome, which is our utility token, one that we also have. So let's say that $60, you will get $60. Do you want to participate in this research? You're then free to say, yes, I would like to know more and I would like to participate in this, or no, right? The most important bit is you have a say. You directly have a say, and no more the model whereby the intermediary has a say, and whereby the intermediary also doesn't feed you any information back. You are not kind of kept in the loop on everything that is happening with your data, and at the end of the day, it is your information, right? So we allow you to regain back control over your genomic information with our infrastructure. So very quickly about the market. So the genomic testing market is huge. There's loads happening there. It is very rapidly growing. It is a very fertile market. Loads of things are happening there, but that also comes with challenges. I was just saying to Dr. Cameron that there was a recent article published in IEEE whereby a group of scientists, they looked at all the new sequencing methods out there. They call that next generation sequencing. And they commented on a recent article published in Nature whereby they said, hey, we can already, we would be able to sequence your genome just by getting a bit of air around you, right? So no longer blood, no longer saliva, we just need to be kind of around you to get your DNA, right? Now, I don't know if it's already out there working, but what I do know is that these sequencing technologies are rapidly advancing. What these scientists saw in this article is they said we've overinvested in the sequencing methods and we've underinvested in the security technologies to keep the data safe. So what we're going to suffer is, unfortunately, very likely a cyber hack, because the data, it's too tempting for people to try to get the data when you know that it is an exponentially growing monetary value, that it's highly personable information, and that loads can be done with it. It's not only the scientists that comment on it. In a recent interview, Barack Obama talking to the name escapes me. It's not Wired, but it's another one. I will do my research. But he basically opens the conversation saying we're not far off from a malicious government potentially developing a biological weapon on the basis of data that they've hacked out of a specific database, right? So why I'm saying this is that it is time to double down on the cybersecurity around data that is so extremely sensitive, right? And we hope to be at the forefront of that, and we hope to, and I of course welcome all your comments and ideas around this, but we need to invest more in the security of such information and potentially less in kind of advancing how quickly we can get it. Because we know that we can get it, we know that we can advance our understanding very quickly there, that is all known. Now let's focus on the bit whereby we need to look at the security of everything so that all of us are safe and we can advance science in a way that works for all of us, every stakeholder, not just the big lab that gets that cleverly managed to allow you to wave your data. Okay, so what types of technology do we use? We use secure encryption virtualization technology. We use the tools of a company called AMD, the biggest chip maker in the world. They're a multi-billion-dollar company. We use their secure encryption virtualization technology. That's where we build our software from. And we've paired AMD with blockchain technology. We don't put any DNA information on the blockchain. That would be the wrong pitch of our company. We use blockchain to ensure that we work with one version of the truth. We keep an auditable trail of whenever your vault is being used for scientific research or when you've run a health report on it. And we use it for what we've developed is a unique repeat consent protocol. So that allows basically any querier or anyone who wants to study your data to come back to the vault with a new research question. And again, what the researching organization receives is only the outcome of the research. It's the answer to their research question, never any data, so that we don't defeat our own purpose. So there's never any data leakage. The data remains in the vault, and you, as an individual, are the only one who can take out the data if you want to do so. We, as the founders of Genomes.io, wouldn't be able to open the vault either, right? So that is also a promise that we made. It's like we really want to be, and we are already, the world's largest user-owned genomic database in the world. And so we pride ourselves of the fact that we are, and we want to grow in that direction. Okay, so here's a little bit about the technology, and I appreciate there are deep tech people in the room. So here's a little bit kind of what it looks like. The app is live. I'm happy to say that we have thousands and thousands of users active on Genomes.io. We're growing in the hundreds each week momentarily, so we're very happy with that. We also recently, and this was to also go against what was happening with companies like 23andMe, allowed all those victimized by 23andMe to vault their VCF on our infrastructure. So for them to regain certified ownership over their data, to vault it and to reap all the benefits that we offer, that they were deprived of by going with a company like 23andMe. And that was successful. Many people came over to us and they dubbed us, and we'd like to hear that, like the decentralized version of 23andMe. So that is a little bit about our technology, and I'm happy to address that later on. We also, we're very happy that this was the first, but very recently we did the second one. We completed the first crypto incentivized, auditable, anonymous genomic study in the world. And why is that so important? Because previously companies like 23andMe, Ancestry.com, or any other organization that use genetic data, they say, we would love to get back to you as an individual, not violating your privacy, doing all those things. But technically that isn't possible. So they were always hiding behind the fact that the technology wasn't there yet, right? And as Dr. Cameron also said in her talk, the technology is there. right? So we were very loud about this, that saying like, don't tell me that the technology isn't there. The technology is there. You choose not to work with it, but that's what you need to say then, right? Don't say like, no, listen, the technology isn't ready, we're not ready for this or whatever. That is frankly nonsense. And we have executed on it for the first time, and just last week also for the second time, whereby we did a paid study on something completely different. This was on long COVID, but on something completely different, which is whether you have it in you to become a daredevil or to be a daredevil, whether you have an adventurous spirit, which is also something that can be measured genetically. So it was a quirky thing, but many people liked it, and they also, of course, liked the fact that they were compensated for their contribution, for allowing their vote to circulate in this research. I'll get to the end of things. So here's our growth. We have welcomed big investors such as Consensus, biggest blockchain company in the world, Pantera Capital, a big hedge fund active in the crypto community, Modular, which is another fund. So we're very happy to be working with them, very happy to be growing, and as a result also of kind of their investment, which happened in June 2024, we kind of skyrocketed in our growth, and I'm very happy to say that we're continuing this journey with loads of people being involved. And last but not least, we're also embracing artificial intelligence. Now, artificial intelligence was a bit of a tricky one, because as a technology company, you can't actually say, you know, let AI be, right? We felt that was no longer an answer that we could give. At the same time, as a solution, we stood for privacy, security, and safety of our users. So we didn't want to just feed genomic data into this big learning machine, not knowing where that was going to end up. And then Pantera Capital, that also invested in BitTensor, introduced us to the founders of BitTensor, and together we developed a kind of a blueprint to become the first subnet for human genomics, whereby we do not use any real-life human genomic data, but we use synthetic genomic data. So there are 20-odd synthetic genomic databases out there, and we were to use these databases to essentially feed our subnet so that together we can develop predictive AI algorithms for drug discovery. And we would start with drug response. And so we're very happy that we were able to do that. And with that, we welcomed, and I announced it when I spoke in Edinburgh last time, we welcomed another investor specialized in this by the name of Contango Labs. So we're very happy to work with them specifically for this AI end, because a subnet, I don't know who of you knows BitTensor or knows how kind of that's developed, is a synergy between validators and miners, whereby together they develop this open source AI. So the benefit is that it's going to be transparent to all. You're going to understand the algorithm if you want to. You can take a look at it on BitTensor. We would never own the algorithm, but we would use it to essentially grow our drug discovery arm, so that pharmaceutical companies and drug development companies would be interested to use it to verify their assumptions, but then with synthetic genomic data. Long story short, I hope I didn't take you too far down in the genomic rabbit hole. Yeah, we're growing. Here a little bit of who we are. I'm not the scientist. I'm not the genetic scientist. That is my co-founder Mark. I'm more a technology guy building tech companies. And here are some people in our advisory board. And that's it really. So let me just pause there, and then hopefully you have loads of questions so that we crack on with. Thank you very much.